So just to review, what we just ended up doing was looking at embodied energy in a gold refining process, and it was a perfect example for gold. We used smaller numbers, as we mentioned previously. We didn't take all of Missoula and look at all of their plastic. We went right back to fundamental specific heat equation, nothing too fancy, the changes in temperature, the mass, the specific heat of the material. And that's a super bottom end number, that 400 and whatever joules we came up with, 405 joules. We went and looked up what the energy density of propane was. We did some units conversion. We talked about the fact that you could take this and stick it into an Excel spreadsheet and have fun with it all day long for whatever material is your favorite. And as it turns out, I've got it from the first forum. Looks like everyone's kind of got their favorite material. It's fun. Everyone's a little different. Or favorite artifact. And again, just about everything we've talked about can either be an artifact or a material. So, but let's get into the forum and catch up there. Make sure everybody's on the same page. Answer any general questions. Okay, I got one post. It would be nice to see a few more before we get into next week. Oh, and just while I'm mentioning it here, I did extend the deadline for Quiz 2. A couple people weren't quite on the ball for Quiz 2, so please go ahead and take that. And let's see what Sean has to say. PVC, embodied energy. See if I can make this a little bigger for you. Okay, so you took the numbers that we looked at from the website, 72.2 megajoules per kilogram. Yeah, it's funny, the gold example we just did, we were looking at 4 megajoules per 3 grams, so we were at, we were actually in the gigajoules per gram for gold. And so you could have even more exclamation points after that guy. Carbon, 2.41 CO2 per kilogram. Now, here's my question to you, and I don't know the answer. It's worth researching. Does this CO2 release, is that a release as a result of the physical process of processing the PVC, or is that more you had to put that much energy in, so some coal was burned somewhere in order to make it that hot? Do you know the answer to that?
That's exactly what I was wondering.
You're not sure either. Yeah.
That's why I didn't put it in the process of making it. I left it.
Right. Yeah. And that's something that I don't. And I don't know the answer either. I don't know enough about the chemistry of manufacturing PVC, whether the CO2 is coming off as an off-gas process. It's worth looking into, and maybe I'll just kick back in the forum. From the skills from 101 and 102, you could say with that many megajoules, if you're running a gas-fired power plant at 30% efficiency, how much CO2 would come off, and you could do those numbers in a hurry. After polyethylene, yeah. So let me throw that back out to the forum, and I'll just throw it out as a little research question. Is this a result of the process of manufacturing PVC, or simply a result of the let's see, resolve the, let's write it this way. You would, yeah, absolutely would. You would want to include both, and maybe it is both, but it could also be an either or.
In which case you're missing half of the point is how much energy. So is the question, there's the embodied energy going into it as well as the embodied energy that it takes to break it down? I must have missed it.
Well, so my question, so Sean has a good point, and he threw the CO2 thing out there, and it was, because it was listed in that, and let me just take a quick peek. Well, while we're at it, let's just look at the chemical formula for PVC. I don't know it off the top of my head. Images, polyvinyl chlorine. Let's do it this way. Molecular formula. Oh, so it's polyethylene, except you got chlorine in there still. Pretty dang simple. Super simple. Now, in this case, I'm just going to look, let's just look at this guy. Here's the monomer. So this thing is a gas, and let me just see, formula, chemistry of manufacture. I'm guessing there's more to the story than what we just saw there. Let's see if we can look at it here. Let's see if we can get to okay, here we go. VCM and water are introduced in the reactor. Water is continually added. Initially, breakdown, fragile, two different modules. Degassed. Here's the question. When they say degassed, it would be good to know what those gases are. Because obviously water is going in. There's oxygen in the water, and in this polymerization, some carbon could be coming off. So it could be that there's some CO2 coming off directly from the process. Let's just go back down and see if that's actually given to us anywhere. I'd love to just see the full chemical reaction, but it's not. Woo! Black trousers. So that would be a good, if any of the, and here's where I can just kind of shout out to some of the environmental studies folks, because this is being offered as a 400 level class in environmental studies, and this is some chemistry that I think would be appropriate for those folks to chime in on. So is this a result of the chemistry involved in polymerizing? And basically what we're looking at is polymerizing, let's just say the polymerizing the PVC monomer into the PVC polymer. And we saw that or simply a result of the energy used in manufacturing and the associated carbon dioxide from fossil fuel combustion. So I'll throw it back out there. I'll do some research on it too, but it'd be a good, it's a good start of the discussion there, Sean. Thanks. All right.
So would you like this to probably?
It doesn't matter. Really, if this is interesting to you, keep it going. If there's something else in the embodied energy that's more interesting, take your favorite material. And I know, for example, Jason, you're more interested in the organic waste, talking about compost and all that. So there's many directions that could go. One could be the embodied energy in composting. What does it take you to walk the organic material out to the compost pile and dump it? You could run those numbers because we know that your human body is run at 115 watts and however long it takes you. Oh, and then by the way, are you gonna pitchfork the thing? Or are you gonna roll it in the drum? So again, you're sort of putting energy into the composting process. Now, the thing to keep in mind though, in composting is that the pile itself is alive. And so there are a lot of microorganisms in there heating the thing up. So they're actually giving heat, which gives rise to other microorganisms coming online to do their thing. So and again, I'm not going to expect you to get too far into that biochemistry because
solar energy, I'm assuming.
Could be, yeah. If you've got some solar going in there, I know also that you really do need the water in there to keep the metabolism rocking and rolling. So yeah, if you want to start a organic matter embodied energy thread, go for it because it can take a lot of dimensions. But this is a good one. I mean, what you brought up is a perfect thing for the forum. So let's just keep rolling with it. All right. So the last thing I want to talk about, and this is just kind of a challenge, and we'll start this little forum up next week for real. And I didn't want to mention it the very first week of class, but I figure now that I've got everyone's attention, I really do want to throw the challenge out there to the class to get off the landfill if you can. I mean, I know it's going to be harder for some than others, and and one pretty easy way to do it, and this is just an example, I don't mean to pick on you at all, Priscilla, but as we were leaving lecture, and I'll give an example. As we were leaving lecture last week, it's not still in here, I checked. But this is the trash can that's sitting in the classroom. And I've talked to the custodians about this, and they say, we got to have a trash can in every single classroom, because otherwise the classroom will be trashed. Students will leave behind their blah, 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 whatever. Okay, so in here, I have a couple banana peels. And so last week I saw Priscilla kind of absentmindedly chuck her apple core in there. So sorry to pick on you. But for me, I'm looking at this thing, and if we were able to get the digester, the apple core, the banana peel, et cetera, would just go right into there, and this banana peel would become dirt, it would become soil, it would become nutrients for the next generation of food that we eat, rather than becoming a giant methane bomb in the landfill that we have to set on fire. Because that's exactly what's happening. So, the white sheet of paper, obviously, that can go in the white paper recycling. This guy, let's see, we've got a number 6 polystyrene lid. This is probably some kind of, it's crinkly, might be an LDPE or an HTP, so this is probably a number 1 or a number 2. And this tea bag, I mean, that's as good as dirt right there, too. The cup itself, I'm thinking this can go with either paperboard or cardboard. From what I saw at the recycling center, this cup can go right in with the cardboard, no problemo. And what else? There's a tiny bit of thin film plastic in there. This guy can go into our Patrick Brown EPA-approved waste to energy stream. Here's your little haul. Somebody's probably sick, so I'm probably going to get sick touching someone else's garbage. Sorry, but on the other hand, maybe I'll be inoculating myself because I have a strong immune system. And again, this could go waste to energy. Maybe it should go into the bio-waste stream. And, right now, I've also been working with Patrick Brown and a couple other engineers to turn this right into energy, into heat. But why embody more energy driving this thing across town, up a hill, and putting it on top of the land? It's just bizarre. I just do not get why we still need to use the landfill. And I've just kind of triaged this little thing. I also, and if you want, for a little bonus, we won't do it here in class, but I mentioned the fact that a bear went through a neighbor's garbage. It's that kind of time of year, and my other neighbor was sort of shuffling it off the street in front of his house. I said, here, I'll take that. I want to use it as an example in my recycling technology course as a sort of a challenge problem. And as it turned out, the thing the bear was after, there was a jar of peanut butter in there. I mean, there's kind of other wrappers and crap. And somewhat ironically, it's like the fancy organic peanut butter that separates. So you know how all the oil goes to the top, and then the nice chunky stuff that you really want to be eating is the bottom. But for whatever reason, whoever had that wasn't strong enough, courageous enough, whatever, to stick their knife or their spoon and get the dang peanut butter out of it. So right there's an example of a lot of embodied energy, both that took to make the peanut butter, and that could have been used to contribute to that 10 megajoules per day that we all need. It's just going in the garbage, and then the bear eats it, and then the neighborhood children get scared, and then we got to kill the bear. So, that's why I really do challenge you to get off the dang landfill and not leave your half-eaten jar of peanut butter out by the curb for the bear to come eat. It's just it's not good for anybody. So, I'll be digging through that out of my bike, and I will be leaving a compost bucket. Where should I leave the thing? Should I leave it over by your cell phone gizmo? Shelly just put up a neat cell phone reclamation right by this recycling center, so maybe I'll do that on the way out of class. I'll take my compost bucket. I took my own trash can from my office. I took the liner out of it. It was this thing is. What is this? I don't even know.
You're talking about food scraps and such?
Food scraps, yeah.
Can we put them near the entrances on the outside? That would probably get more support.
But is it going to smell? People are going to complain about it.
It will smell if it's left there for more than a day.
That's what
But it's not. Why would it smell any more than the garbage that everyone's sticking their half-eaten sandwich in? It won't smell more than that. No.
The two reasons I was
I'm just saying,
thinking,
you
Yeah.
need to have it come back.
We'll empty it every dang day. Yeah. Question. Sorry. Yes. Go for it, please.
the two reasons I was thinking of going with smaller collection stations is, number one, you have to empty them every day. And number two, it shows, three reasons, I guess. You can see what the breakdown is, what the participation is. You've got to clean them out of necessity.
Yeah.
And plus, I think people see that activity.
Oh, I see, yeah.
And so it brings more awareness to, that, I think conscientiousness. I mean, we can all talk about, hey, we all got to pitch in and do stuff like that.
Yeah.
But ultimately, it's easier if we can recruit others.
Yeah.
Through.
I hear you.
Some of us will graduate.
Well,
eventually.
I hear you. Yeah, and I think what you're talking about is moving away from the business as usual, which is, pretty much this thing, and moving towards
Well, we've
something.
got some bins out there, they're the same size as garbage cans.
Yeah.
And so people don't really see much activity there, they just walk past it.
Yeah.
And, I don't think it really invites participation.
Well, a couple weeks ago, if I recall correctly, we actually did draft a recycling policy for the university. I'm going to run that right over to our sustainability coordinator on Wednesday. I'll show it to Royce. Sounds like we're spending $500,000 a year on waste and recovering almost none of it from materials, and we need to turn that boat around too. Yeah.
And I really think what Brian was talking about, the education
I've been pushing that.
Oh, right, I see.
That agenda.
Instrumental
Mm.
in,
Awareness
yeah, because.
and participation.
Yeah, well,
Busting out
yeah.
fires isn't gonna do
No,
it.
yeah.
Talking isn't.
I've been
that
pushing for this
would be
agenda
a
since last
really
year.
big
Yeah.
deal.
So what you're saying, though, is in a similar way that in order to register for courses, you have to
Yes.
acknowledge that you are sexually aware with the whole
That's the
PETSA
one, the
thing.
SARC,
Yeah,
that everybody
yeah,
has to take.
yeah, and
then
that
I
you're,
think- I think, you know.
be a participant in the universities, in other words,
And
that
that's
you're,
data that we can
responsibility.
collect.
yeah,
Sorry?
That's data we can collect. How many people
Yeah.
got it wrong after watching? How
Mm.
many people?
Well, how many preconceived
Didn't know.
notions, a lot of times you
Yeah.
can see what the mindset of folks, if
Mm,
at all,
mm,
is
mhm.
coming in, and then
Right.
we can, it's so much easier to address objections if you know what they are.
oh, sure, yeah. Use it as a entry survey, so whatever
Absolutely.
answers people have towards their waste habits, we could look at, sure, I like that, okay.
I think, again, it's like, you know, I can sit at the bottom of the hill and throw rocks at the problem, or I can find 4 friends and we can go to the top and start an avalanche.
Yeah, yeah.
So waste survey would be good in orientation.
Absolutely. That's what I've been pushing.
Initial survey,
Mhm.
I'm trying to get the ball rolling.
Yeah.
Then the Moodle thing that they go, it's a little more intense.
Well,
But I'm already preaching to the choir.
I will do what I can on the sustainability committee
Mhm.
to see if I can't turn the university into a zero
Thinking
landfill
of
model.
today.
Yeah, yeah, I know, yeah, I'll be there. I'll be there.
I think you could like recover from something. I mean, if Royce's, you know, we have that solar thing that's, you know, probably not gonna happen, the carbon, all this crap, but, you know, let us excel at something.
Mm-hmm,
Let the university stand for something,
mm-hmm.
you know?
Well, and he definitely needs to lead the way. He needs to take a leadership position because he's not.
Okay, think
Yeah.
about
He's-
that.
Oh, one quick sec.
Yeah.
Yeah, one quick, no, it's okay, we can save the political statements. Well, it's true, in any, I mean, in any political environment, in any,
Do you want to turn off the recording?
no, it's okay, and I'm not gonna, I'm just gonna make a general statement. That we would love our leaders to lead us in the direction we want to go.
Oh, yeah,
But-
love our leaders, yeah, keep recording.
But what I really wanted to say though is that I am going to have a few questions up there for a quiz 3, and they will be along the lines of some of the embodied energy stuff that we just did today. So be on the
Because we
lookout
got
for that.
math, we had to do any math.
The question is whether or not we have to do math,
I mean, in
and
the quizzes.
if I am not sending my graduates out the door with quantitative skills, then I'm not doing my job. Is the answer to that.
Well, that kind of
It's an
comes.
age,
I did.
Oh, wait.
If I am not sending you out the door with
Actually,
quantitative
brings us
skills,
around
then
to
I.
this other article I had, which is the sustainable camp, this
See you
is
next
going to
week.
be the model for, you know, we've got the Sustainable Campus Committee